Welcome back to Tracing the Sky. So in the last episode, we saw how a lot of what Aristarchus was doing was starting to come together. What we'll do quickly is recap where we're at and then add the last piece to his puzzle to see how he figures out the distance to the sun and the moon. So let's jump right in. So here's a snapshot of where we left off. We were really focused on a lunar eclipse. That's when the moon passes through the Earth's shadow. So this white line here represents the Earth's shadow at the distance of the moon, right? And what we cared about specifically was understanding the relationship between the diameter of the moon, the diameter of the Earth's shadow, and then the diameter of the Earth itself, right? So the diameter of the Earth itself. And we wanted to see if we could relate those things, because if we can figure out the diameter of the Earth and its relationship to the rest, we're very close to figuring out our ultimate answer. We could use the diameter of the Earth to figure out the diameter of the moon and the distance to the moon, and then ultimately to the sun. So let's see how these things relate to each other in more detail. Let's start by focusing on this equation up here and reminding ourselves how we got it. So first of all, what we're looking at, what this ratio represents, is the ratio of the height of this triangle to the base of the triangle. We can represent the height with this pink line here, this pink line here. So this is the height of the triangle, and this green line is the base. Well, the base, this green line, is just the distance to the moon, right? From the Earth to the moon, that's just the moon's distance. So that's what this green line represents. Now, the pink line, we don't know exactly what that is, but we can represent it as the difference between the radius of the Earth less the radius of the shadow of the Earth, right? You can see how this entire line here is the Earth's radius. If you subtract from it the radius of the Earth's shadow, then you're left with this pink line here. And so that's how we get the top part of this, right? So the pink line is equal to the Earth's radius minus the Earth's shadow. So the ratio of this triangle is pink over green, or the Earth's radius minus the Earth's shadow radius over the moon distance. Okay, so that's one side of our equation. The other side of our equation is pretty similar, right? We have this portion of the circle, or of the triangle. The height of this triangle is this pink line here. Well, that's just the radius of the sun minus the radius of the Earth, right? This portion here. What's left is this pink line. So that's this pink line here. And then this other green line is just the distance from the Earth to the sun. So that's how we get these ratios, right? So we get those ratios. Now, why are these equivalent, right? Why did we write them as equals? Well, if you remember from the last time, we know that there's a relationship between the moon distance and the sun distance. We also know that these angles are the same here. These angles are the same for both of these triangles. So we know that the ratios are the same. This is, in Aristarchus's numbers, 19 times larger, but that specific value doesn't matter. What matters is if you divided these sides. If they share the same angle, then the ratio of the sides must be the same, even if their actual sizes are very different, right? Even though this is proportionally 19 times further away and larger, the ratio of the sides is the same. Rewatch the last video if you need a reminder on why that is. But that's why we can write these two formulas as equivalent. These two equations are equivalent to one another. The ratios are equivalent to one another. So now let's take our last step and start to understand how we can simplify these equations, or this equation. So let's start with one substitution. We're going to break this down in really small steps so we can follow together. So instead of sun distance, we know that the sun distance, or the distance to the sun, is actually equivalent to something. According to Aristarchus, the sun is 19 times further away than the moon from the Earth. And so instead of sun distance, we can put 19 moon distances at the bottom here. Our goal is to simplify things, right? We have a lot of things going on. We've got this radius of the sun, the distance to the sun, the Earth radius, the shadow. Let's see how many of these things we can swap for other things we know about so that we can simplify the different moving pieces. So we can rewrite the equation like this. We can keep the left-hand side the same, right? The Earth radius minus the Earth shadow radius over the distance to the moon is now equivalent to the sun radius minus the Earth radius over 19 moon distances. So we've gotten rid of a sun distance and we've replaced it with something we know about, which is great. Now let's take another step in simplifying our equation. Before I give you the next step, I want to remind you and encourage you to try and solve some of these steps, or at least pause and think about the steps as we're doing them and see if you can find a pattern. If something does occur to you, take a moment to pause and see if you can solve that step before watching what I do. I think that would really reinforce these ideas. So the next thing Aristarchus can do, or that we can do, is multiply both sides by 19 moon distances. So we can multiply both sides by 19 moon distances. If we do that on the right-hand side, then we'll be able to cross out this moon distance, right? If you multiply this side by 19 moon distances, you get to cross this out. And then if you multiply this other side by 19 moon distances, well, what you can do is you can cross out the moon distance, right? You can cross out this moon distance and this moon distance. So ultimately what you're left with is this equation. 19 times Earth radius minus Earth shadow radius is equal to the sun radius minus the Earth radius. Okay, so notice we're simplifying things a lot. We've now gotten rid of moon distances altogether. Now we have a relationship between the Earth radius minus the Earth shadow radius and the sun radius minus the Earth radius. We know that there's 19 of those, which is equivalent to the sun radius minus the Earth radius. Well, let's see what happens next. So the next thing we can substitute out is the Earth shadow radius. Remember that one of the really fascinating observations Aristarchus made was to look at how many moons fit inside the Earth's shadow during a lunar eclipse. He timed how long it took the moon to travel through the Earth's shadow during the eclipse, and he realized that it was a 3-to-1 ratio. 3 moons fit inside 1 Earth shadow. Well, regardless of if you're comparing the moon diameter to the Earth shadow diameter or the moon radius to the Earth shadow radius, the ratio is 3-to-1. So 3 moon radii are equivalent to 1 Earth shadow radius. So we can rewrite this equation like this. All I've done is I've substituted Earth shadow radius for 3 moon radius. So the equation now is 19 times Earth radius minus 3 times moon radius is equal to the sun radius minus the Earth radius. I'd be very curious if you're starting to see where this is going, right? The next thing we can focus on is the sun radius. And I wonder if you can think about what we can substitute this in. Notice how many fewer terms we have. Right now we're only down to 3 unique variables: Earth radius, moon radius, and sun radius. We have another Earth radius here, but we're getting close to just having the simplest version possible, which we'd love to get to. We'd love to now figure out how the Earth radius relates to the moon radius. So let's turn our attention to the sun radius next. So to get rid of the sun radius, or to replace the sun radius, we have to go back all the way to one of our first videos on Aristarchus. Remember that one of his big first realizations was that the sun was 19 times further away from the Earth than the moon was. And because they both appear to be the same size in our sky, that must also mean that the sun is 19 times larger than the moon. So the sun is not only 19 times further away from the Earth than the moon, but it's also 19 times larger. Well, all that means is that the sun radius is equivalent to 19 moon radii. So we can rewrite our formula like this. 19 times the Earth radius minus 3 moon radii is equal to 19 moon radii minus the Earth's radius. So now we only have 2 variables. We've got Earth's radius and moon radius on one side, and moon radius and Earth radius on the other side. So let's see how we can simplify this even further. And what we're going to do is divide both sides by 19. So let's see what happens when we do that. Okay, well, we've divided both sides by 19, so we can simplify our equation. We can cross 19 off on this side, and we can cross 19 off here and replace this with 1 over 19. 1 over 19. Here, let me rewrite this so that it's a little bit cleaner. So that's just equivalent to an Earth radius minus 3 moon radius, right? That's what we're left with if we divide the left-hand side by 19, is equal to a moon radius minus 1 over 19 Earth radius. Now, there are a couple ways to solve the rest of this. I'm going to show you kind of a little shortcut that we can use that will give us approximately the right answer. Remember, the distances we're dealing with are so vast that some amount of minor error isn't a huge deal and makes it a little bit easier for us to work with. So if you were to solve this the harder way, you would get a more precise answer, which you could totally do. I'm going to, like I said, simplify it just for the sake of making it a little easier to wrap our heads around. So the simple way to move forward is just to look at this right-hand side of our equation. 1 moon radius minus 1 over 19 Earth radius is essentially a moon radius. This number is so small, right? Taking 1 over 19, right? It's a very small ratio. Means that the amount you're subtracting from the moon radius is almost irrelevant, right? So you can essentially just rewrite this and say, well, an Earth radius minus 3 moon radius is equal to about 1 moon radius, right? You can just simplify it like that. You can just say this number is so small that Earth minus 3 moon radius is about a moon radius. It's essentially the same thing. So that's the simple way we can do it. And then it becomes very easy to solve this, right? You can just add 3 moon radius to either side, and you can essentially just say, well, the Earth radius is equal to 4 moon radius. And one thing that's kind of cool here, I'll show you, is now Aristarchus can figure out the moon's radius if he knows the Earth radius or vice versa. If he knows how big the Earth is, he can just divide it by 4, and that's how big the moon is. He also can figure out the Earth's shadow. Remember, the Earth's shadow radius is equivalent to 3 moon radius. So essentially, the Earth's shadow radius is 1 moon diameter smaller than the Earth diameter. So he has all of these things now he can equivocate between because he knows this relationship. So the huge part, though, is if he can figure out the radius of the Earth, he can then figure out the radius of the moon, and then he can plug that into all the other formulas he created, right? He knows the relationship between the radius of the moon and the distance to the moon. He knows the relationship between the moon and the sun. So if he can figure out the Earth's radius, he can get all of the other values. Well, we have come such a long way. Aristarchus started with knowing nothing about the size of the moon and sun and their distances. And now all he needs is one more piece of information. If he can figure out the size of the Earth, he can figure out the rest. So in the next episode, we'll tie all of this together and do a brief summary and see where we go next. Can he or somebody else figure out the size of the Earth and then tell us all of the other things we care about, the size of the moon, the size of the sun, and their distances? So join me next time to find out.